Hello, so my name is Priti Sarve, and in this video, I'll demonstrate my DevOps assignment where I containerize a Node.js movie application. To provide an overview of the project, it implements a simple Node.js movie application which is containerized using Docker and deployed on AWS EC2 instances. Jenkins is used to scan Terraform infrastructure code using Trivy, and an intentional security misconfiguration is introduced, detected, analyzed using AI, and then fixed. So before deploying to the cloud, the application is first built and tested locally. The backend Docker image is built locally using Docker build, and to run both the backend and front end together, Docker Compose is used. So this Docker Compose command is used to start two containers. First, the movies backend. This is running on the port 3003, and next is movies front end, which is running on port 3000. So this step ensures the application works correctly before deploying it to AWS. After validating the application locally, it is deployed on AWS using EC2 instances. So this is the instance used to host the application. So on the backend service EC2 instance, Docker and Git are installed, so containers can run directly on the server. The Git repository is cloned using git clone, and inside the movies directory, the existing Docker file is used to build the production image directly on EC2. The container is started with port mapping from container port 3002 over here to EC2 port 80, exposing the backend publicly. The Docker Compose file is used again to is also installed on CLI plugin, and from the repository root Docker Compose minus build, which is over here, Docker Compose up build is you executed, and this command builds images for both the backend and front end and creates a Docker network, which you can. So this is the IP where it is hosted, and when you open it, the same IP, the application is hosted on the EC2, is running successfully on EC2. So this is available via the EC2 public address, which I just showed. So both the backend and frontend are hosted here using Docker, and the application is accessible over the internet. Next, the Terraform is used as an infrastructure as a code, and it is used to provision EC2 instances, security groups, networking related configuration. So this is the EC2 used for Terraform. So also an IAM user is created. This is the Terraform user created. So this user has administrator level access over here. So this, which is it is required for services like EC2, VPC networking, and IAM read permissions. Also, security groups are defined in Terraform to control inbound and outbound traffic. Initially, a security vulnerability is introduced by allowing SSH access on port 22 from this CI/CD block over here. So also the Terraform commands like Terraform init, Terraform plant, and Terraform apply are used, and once after apply, the EC2 public IP is generated by Terraform. So here you can see the IP address which is generated. So after this, next is Jenkins. A separate instance is again used for Jenkins. So this allows Jenkins to run CI/CD pipelines, scan Terraform code, and control infrastructure deployment. So before starting the instance, Terraform, Trivy, and Jenkins were installed first using the CLI, and this is the public IP address used to host Jenkins. Once we open it, this is the Jenkins. We land up here on the sign in page. I will enter the username and password. So this is the dashboard which we see. So before starting with Jenkins, I installed a few plugins. For example, this is the Git branch source plugin which I installed. Also, I installed the AWS credential plugin, which is used to store the Amazon IAM credentials. And after this, I also added the AWS credentials. So Jenkins securely stores the AWS credentials inside Jenkins credentials. So next is the Jenkins pipeline. So once we open our project, there are various stages in the pipeline. So the first stage is the checkout stage. This is used to pull source code from GitHub. The install stage, which runs the npm install. The build stage, which attempts npm run build. The infrastructure security scan, which runs Trivy on Terraform code. And the Terraform plan stage, which executes only if the scan passes the infrastructure security scan. So this ensures insecure infrastructure changes are blocked automatically. So to show a failure, if we check the build number 9, the console output shows that there is one misconfiguration in the main.tf file. It shows that there is one failure, and it is due to the CI/CD block the CI/CD block, as it allows SSH access, which is open to all the IP addresses. So after this, I provided a prompt to AI showing this failure pipeline, and AI provided me with changes, recommended a fix, and once I rerun the fix, this is the next bit which successfully implemented the pipeline. As we can see here, there are 0 misconfigurations in main.tf, and there were no security findings detected. So, and this pipeline was successfully implemented. So in conclusion, I successfully implemented the DevOps assignment using Docker, Terraform, Jenkins, Trivy, and AI-based security remediation. Thank you.